Okay, 10.6 is solving radicals. Yep, we're going to find out what the values of x are involved in these radicals. Step 1, we're going to make sure the radical is on one side of the equal sign by itself. Step 2, we're going to raise both sides to the exponent that matches the index of the radical. So that means if it's a square root, then we're going to square both sides. If it's a cube root, then we're going to do to the third power on both sides. And then that's going to make it so that we can solve for x. And then we're going to come up with some answers, but not all of them will truly work. So we have to be really careful that we check our answers. That's something I've never had a good habit of doing. But when it comes to this section, can't get them right unless you do. We will have some questions that have two sets of radicals in the problem. So if you go through these steps, raising both sides to the exponent, and you still have a radical in the problem, then you get that radical alone, and then you raise both sides to the exponent again. And then it will be ready for you to solve for x. So here we're going to start with an example. So we have the square root of x minus 5 equals 1. Alrighty then. Now, when we're doing this, notice that the radical is not alone on one side of the equal sign. So I'm going to go ahead and I'm going to add 5 to both sides of the equal sign so that we have the radical alone on one side of the equal sign. All right. So now we've done step 1 where we've gotten the radical alone on one side of the equal sign. Step 2 is to raise each side to the exponent that matches our index. So this is a square root, so we want to square both sides. So we're going to go ahead and say this squared and this squared. Well, if you do the square root of x times the square root of x, we've done that before. Think about that. Square root of x times square root of x gives us the square root of x squared. And we'd say, well, we have one set of x squared in here. So the shortcut to all of this is when you square a radical, it just ends up with whatever was on the inside as your answer. Square root of x squared is just x. And then on the right hand side, 6 squared is 6 times 6, which is 36. So we're saying that the answer is 36. Now, we talked about checking your answer, because this is the answer we want to put in the blank. But we do need to check our answer. We need to go back to the original problem, and anywhere we see an x, we want to go ahead and put that number in that we discovered. So the square root of 36 is 6, and it is a true statement that 6 minus 5 equals 1, and 1 is truly equal to 1. That is true. So when we checked our answer, we found out that it is accurate. When x is 36, this works. All right. So let's try another one. And you know how it goes. They're going to get more difficult, but that's okay. We're going to get there. So we have the square root of x plus 3 equals 8. We're going to get the radical alone. So we subtract 3 from both sides. So now, square root of x equals 5. And if you square both sides, because that's what our index is, we find out that x is 25. Now you may have already seen that and known that is what the answer was, because the square root of x, the square root of some number equals 5. Well, we kind of usually know that, so you might have guessed that one. So we'll go on to something that's not quite so easy to guess. The square root of 2y minus 1 is equal to y minus 2. All right, so The radical is by itself. That's good news, so we don't have to do that step. Second step, set it to the exponent of the index, which is 2. So we're going to square both sides. This one's going to take a little more work. So in here, the answer is just whatever was inside the radical. So we have 2y minus 1. But on this side, we have to FOIL it. And so when we FOIL this, we get y minus 2 times y minus 2, first, outer, inner, and last. So we get the result of y squared minus 4y plus 4. So we'll put that over here, y squared minus 4y plus 4. Now remember, our goal is to solve for y. So this is where we go into what we remember about in the factoring chapter. When you want to solve for the variable, you have to make sure the equation equals 0. So that's what I'm going to do. I'm going to subtract 2y from both sides. And I'm also going to add 1 to both sides so that one side of the equal sign is equal to 0. All right, now we're talking. So here, now we can factor this. And so when we break this down, the first in each set had to be a y to create y squared. And to make 5, it has to be a 5 and a 1, because 1 times 5 gives me 5. Now getting the signs in there, I don't know if you ever heard this, but the sign of the middle term always goes on the biggest number. So this was a negative 5, and then these two had to create a positive 5, so that means this is also negative, because negative 1y and negative 5y gave us negative 6y. All right, so we factored this, and then to solve it, we write each of them as their own equation equal to 0, and solve for y. So we add 1 to both sides there. We would add 5 to both sides there. So we're saying that our answers are 1 and 5, but let's find out if that's really true, if both of them work. If we go back to the original equation, we have the square root of, let's try 1 first. 2 times 1 minus 1, and we're saying that's going to give us the same answer as 1 minus 2. Well, let's see, 2 times 1 is 2, minus 1 is 1. So the square root of 1, which is 1, is that equal to 1 minus 2? Well, no. 1 is not equal to negative 1. That's false. So 1 is not a solution, even though we came up with it up here. We checked our answer. Let's try it when it's a 5. So if we say the square root of 2 times 5 minus 1, is that equal to 5 minus 2? Well, that's 10 minus 1, so we're saying what's the square root of 9, which is 3. 5 minus 2 is 3. Sure enough, that's true. Yay! So 5. 5 is the only answer that worked. The solution to this radical is 5. Let's do another one similar to that. So we have square root of 3 minus x plus 1 equals x. All right, so remember step 1 is we've got to get the radical by itself on one side the equal sign. So we're going to subtract 1 from both sides, and we're going to have the square root then of 3 minus x equals x minus 1. And the index of this is a 2, so we're going to square both sides like that. Now, whenever you do that and you have a radical, remember what's inside is what you have left. Alright, so that's what we have there. But if it's not in a radical, you got to FOIL it. So we'd have x squared minus 2x plus 1 after we do FOIL. Alright, we have the same situation we had before. We need to make this equal 0. So we're going to subtract 3 and add x to both sides where they are like terms. So now this says x squared minus x minus 2. Then we're going to factor this. Well, the factors of 2 are 2 and 1. So we know that this is going to be a 2 and a 1. The sign of the middle term goes on the big number. They had to multiply to make a negative, so this one better be positive because negative 2 times positive 1 gives you negative 2. And so now we solve each one of them equal to 0 to find out the numbers that we are attempting to find as solutions. And then we have to test them. So let's start with 2. All right, back to the original problem. Square root of 3 minus 2 plus 1, does that equal 2? Well, 3 minus 2 is 1, so square root of 1 plus 1. Sure enough, 1 plus 1 is 2, right? So yes, 2 works. Let's see if the other number works. Negative 1. So we'll do the square root of 3 minus a negative 1 plus 1 equals negative 1. Well, this is kind of making me wonder right off the bat because a square root never has a negative answer. So it would have to be a negative number plus 1 to equal negative 1. But let's keep going with the math. This is 2 negatives come together to make it as a plus, like that. So we're really saying what's the square root of 4 plus 1? So it would be 2 plus 1 equals negative 1. No, that is false. 3 does not equal negative 1. So negative 1 is not a solution, but 2 certainly is.